may I just say how delighted I am to be giving this presentation, and I haven't been so excited by a topic since the introduction of the spreadsheet, which gives you an idea of my age. And I think that the machine learning has got fantastic potential, not only in its own right, but also because it is a synergy of a lot of skills that have been held by analysts and practitioners within the finance area and beyond, such as operational research, the finance skills itself, system skills, and I think it brings them together in a fascinating and very productive way. And I'd like to just give an exposition of my impression of that in the slides that follow. So Larissa, would you move to the next slide? Thanks. So this is a little bit about me. So I am a qualified accountant, Chartered Institute of Management Accountants, but I also have a system background. I've been an information systems manager. I've been an operational researcher as well. I've also run internal audit departments. So I have experience in finance management, and also for many of the last 20 years or so, I've been a consultant. I spent my time in the 10 years in the energy industry, British Coal in the UK, if any of us remember that, which at the time was a huge business and employed 250,000 people, an extremely complex business. And then with all the changes that were happening in the UK, I moved out and became head of internal audit for a multinational automotive organization. I'll talk a little bit about that in one of the examples. And then I became finance manager of one of their businesses, manufacturing business, and that's going to be the main meat of this presentation. And then after that, I was seduced by tools I was using, so I moved into software, and I've spent the last 20 years consulting and developing in software. And as I hope I've already let you know, I'm very interested and quite excited by machine learning. See the next slide, Larissa, please. So I know this will be familiar to many or all of you, but I thought I'd just start from a foundation and we'll build from that. So this is what I mean by machine learning in this case. I realize it's a broad field and it's a subfield of artificial intelligence. But the definition I'm using is that from the training organization Corbett AI, and their definition is that it's a branch of artificial intelligence that can build predictive functions by analyzing data. So rather than telling the data what to do, we work out what to do from the data. And the areas of machine learning that I'm going to be focusing on, well, the three areas are supervised learning, unsupervised learning, and reinforcement learning. And I picked up quite a nice pithy definition of these actually recently. Unsupervised learning is the study of what happened. Supervised learning is a study of what's going to happen. And reinforcement learning is the study of how we're going to make it happen. And reinforcement learning, I'm not going to talk about today, but I'm doing a lot of work into this at the moment. I'm actually quite fascinated by it because I see reinforcement learning as guided simulation. And I think there are a lot of synergies to be gained here, perhaps between this and scenario planning. So I'm doing some work in reinforcement learning at the moment to look at that. But today, I'm going to talk about supervised learning and unsupervised learning and the subsets of supervised and unsupervised learning. If we start with supervised learning, I'm sure as many of you will know already, with supervised learning, we know what we're looking for. We start with a set of training data, and we tell the model how to behave based on that training data, and then any new data that comes in is placed into that context based on the training that we've done. And if it's on a continuum, then it's regression, and if it's going into a particular category, then it's classification. And in unsupervised learning, we don't know anything about the data. We don't really know what we're looking for. We're looking for patterns. Say we don't know anything about the data, that's actually not true. Of course, we're looking for patterns within the data, and the chief technique there, which I'll be referring to, is clustering, where we can bring the data together into groups that tell us things about that data and its relationships. Next slide, please, Larissa. So the starter course, if you like, for this this presentation is an example of a case that I had when I was running an internal audit department. So I had an internal audit department. I had a staff of about 7 accountants, and it was a multinational. We had 12 foreign operations and 125 auto centres and service centres within the UK. And the initial problem that I had was, how often should we audit these? The thing about the automotive sector and these service centres is that it's extremely volatile and things that can change very quickly. And also getting a handle on how often you should go out to a particular site and audit it, when people might have a preference to go and audit a nice little place in the country rather than somewhere in the middle of a big city. So we have to make sure that everything gets done related to its risk. So I'm going to talk a little bit about the system I put in to control this, which was essentially based on a machine learning technique. Now, this is 32 years ago, so it wasn't known by that name at that time, but I hope you recognize what I'm saying. So the first thing was we systematized the internal audit reports. So we got a complete cross-referenceable list of audit performance so that we could link one site to another. And this allowed us then to produce a Z-score from each site that we audited. So that would tell us how many standard deviations away from the mean on each particular aspect we were looking at each site was. And then we could bring all those Z-scores together. So this was continually being reported and updated as the reports were coming in. And then I had a model which then converted those into an audit schedule, so that the idea was that the audit cycle would be shorter if the risk, based on the previous audit and the Z-score and any other areas of risk we identified, was high. And that then turned into an audit schedule, which then passed back to the auditors. They went out and did the internal audit report, and then that fed back. So the whole system matured itself. So the frequency of audit should be related to the results of the previous audit, but no site should be left for too long. And so the issue that I had was, what's the most effective scheduling algorithm? And just before we move to the next slide, I'll just point out that the techniques that I used to do this then was essentially it was on Lotus 123, which is what I had at the time. When I go to the next slide, I'll explain the actual technique I used, which was Lagrange multipliers, to work out the most efficient cycle. These days, of course, it would all be done using a machine learning technique. It would be done in probably SciPy within Python. But just to show you what happened here, so if you just applied these risks linearly, what we were finding is that you would get a very, very wide variation in the cycles. So some places were very risky, and it would tell you to go out and audit them very, very often. And other places were not so risky, and it would say, well, you don't need to audit these very much at all. And that's what the blue lines on these graph represent. Now, the problem with this is that it's a very volatile environment. And so things can change very quickly if the manager changes, etc. So you don't want to leave too long between the audits, but you do want to have it related to how they performed. Could you just pop back to the previous slide? Sorry, Larissa. You do want to have it related to how they performed on the previous audit. So a good machine learning technique, of course, is to minimize the loss function. So in this particular case, what we said was, well, what we'll do is we'll make the loss function the sum of all the audit cycles. So when the results come in and the audit cycle, it's all been calculated, rather than just apply the cycles linearly, it applies it according to the sum of the audit cycles. So what the model automatically did was just slightly increase the frequency of those audits, or the length of the frequency of those audits for very risky sites. So say for something like 6 weeks to 7 weeks or something like that. And if it did that, you could then get a massive reduction in those sites that were audited less often. So you'd be sure you'd be getting the optimal distribution, so that no place was left for too long. But at the same time, the managers of these sites knew that the worse they performed on an audit, the sooner they were seeing the auditor again. So we did that, put that in, and it was extremely effective. And I mention it because I think that's probably the first use I did of something that would now be probably understood as approaching a machine learning technique. So that's the first course. If we now move on to the main course. Next slide. So I was finance manager 30 years ago now of a manufacturing business, and it was actually a remanufacturing business. So what it did was it brought in alternators and starters from cars, remanufactured them, and then sold them out into the marketplace. At the time, it was quite a largest business, SME business, part of a much larger group, but it turned over £40 million a year, and that was in 1990. And we had sites in UK, France, Germany, and Spain. Now, when I came in, there were real problems. Some of you may remember that there was a real recession in the 1990s, and sales had dropped off an awful lot. But also there were demographic changes happening as well. The Japanese had entered the market, and the whole market was changing. So what I was finding was that my monthly sales forecast I was being given by the marketing department would regularly miss by 10% or more, and this is over £300,000 a month, which was a phenomenal amount of money to try and cope with every month. And what this led to was a very high level of working capital because we weren't selling our inventory, and a shortage of cash. We were missing out on discounts, and we developed all these strategic sourcing agreements with our suppliers. So unless we could get some real handle on how this business was going to behave, these were in danger. Now, traditionally, finance didn't contribute to the sales forecast. It was produced by the marketing department and then handed to us, and in that they put all of their marketing campaigns and all of the things they thought were going to happen. And the other thing to say about this business is that the product range was extremely seasonal. So most people's alternators and starters burned out in the wintertime when they were trying to turn them on in the cold weather. And so we get a huge peak in sales in the winter. So the key thing, of course, here, if you're doing any forecasting, was to distinguish seasonality and trend, to try and understand where the business is going. So what I perceived was the need for a financial tool which would help to understand the business environment and to optimize the business within this environment so that we could control the future rather than analyze where the business went wrong in the past. Because when I first came into the role, there's just an awful lot of firefighting to be done to try and manage the working capital that we had. Next slide. So here is a high-level schema of the model that I put together at the time. And this consisted of a sales forecasting model. And this was all written on a Quattro spreadsheet. Now, I'll tell you about a Quattro spreadsheet. At the time, Quattro spreadsheet was the only spreadsheet that had multiple tabs, which was fantastic. And what's more, these tabs could speak to one another, which was absolutely great. So we developed this model on this spreadsheet, each different tabs, different aspects of the business. The sales forecasting model used time series analysis to produce the sales, which I would put up in competition to the marketing department's forecast. We ran one against the other, and it used a 13-dimensional multiple regression, so that this allowed us then to separate out what was actually happening with the sales in the business from the seasonality of the business. These sales then fed into a factory model, and that calculated for finance purposes the build required to meet the expected sales. It allowed me to calculate limits for my purchasing manager to tell him what raw material purchases I would budget him to have. It would give me an idea as to what the expected service levels were going to be and what the inventory was going to be. And this was all done using multiple regression analysis. And then we had a manpower model. So having determined the build, what manpower did we need to do that build? And so we had a calculated number of directs required to meet the projected build based on the known productivity levels and mix. Now, the problem about a remanufacturing business, of course, is that you are dealing with stuff that's already been used and has come back, so you tend to get very high levels of warranty. And this is a very significant factor within the business. And so, of course, warranty is lagged according to sales. So we developed a model using time series analysis on the historical warranty return data to calculate what the estimated future levels of warranty could be. And that all then fed into a financial model, which would calculate the P&L, balance sheet and cash flow, and allow us to do a little bit of scenario analysis and to change things and see what would happen. And I ran that model for maybe 3 months to prove it against the current systems that we had. And when they saw that their forecast sales, for example, just a sales line, the forecast sales was only £50,000 a month out rather than £300,000 a month out, then people started to sit up and take notice. So we could then, I used to then bring a PC in with me, carry it in physically into the boardroom, put it down on the table and say, right, here's a model, here's the sales, this is what happened last month, this is our deviation. You can see it was pretty close. This is what I think we're getting out of it. And then we'd sit there and play with the model, and it changed the whole tempo of the management meetings, which before had just been forensic exercises. Could you go on to the next slide, please, Larissa? So you can see here the same schema, but now, if I were a much younger man, this is how I would be tackling it. So rather than using the Quattro spreadsheet and carrying a big computer around with me everywhere, I would, having learned what I've learned over the last few years, I would write the whole thing in Python. Even the spreadsheet work, I would use Python add-in like library like Pandas, for example, to do that. And I'm going to talk a little bit more in detail about the specific techniques, but for the sales forecasting, time series analysis, that's of course a regression model. For the manpower model, that would also be a regression model to determine, based on what's happened in the past, what kind of manpower we're going to need for the build. I would also be using a regression model for the warranty. But in addition to that, I would also be using a technique like clustering, because as I mentioned, we had big demographic changes, and one of the changes that we were having was that our warranty was shooting up. Why was that? What kind of thing was it that was causing warranty to go up? Was it the manufacturer? Was it the number of times it had been manufactured? Was it the source of manufacture? What was it? And my general manager used to keep banging on the desk and saying, what's driving that? What's driving that? Tell me, Tom, what's driving that? Well, using something like clustering would help me to tell him, as the data was coming in and going through, what was driving that. And then that would all feed through into our financial model. And in addition to the previous ML we'd used to feed that model, one of the things that I would have done here was actually to look at some pricing analysis using regression. So if we can link price versus volume, because we're very sensitive to price and volume in that business, link price to volume, and then from that work out for budgeting and forecasting purposes what sort of pricing would generate a maximum revenue for us, and what would happen at various levels of pricing. So let's move into a little bit more of the detail. Next slide, please, Larissa. How am I doing for time? Okay. Here's a bit of detail. So on the left, that is the original time series analysis that I did from 1991, and that was in the paper that I did, and that is a printout from Quattro. And as you can see, the business is extraordinarily seasonal. The darker line being the forecast and the lighter line being the historical data. And but in addition to the seasonality, there was a downward trend, and we weren't going to be able to do anything about that downward trend because the environment was changing. So first of all, that flagged up that the environment is changing, and look how seasonal it is. Just because it's Christmas time, don't start employing lots of people. The world hasn't changed. It's only because people's alternators and starters are burning out because it's Christmas. It's all going to drop off after. And that's what that graph showed. So as I say, that was done by 13-dimensional multiple regression. These days, I think we'd call it one-hot encoding, but there's dummy variables. So one variable for each month and then a variable to show trend. It was written from first principles because I had a statistics background. And as I say, it identified the high sales seasonality and the downward trend. So these days, well, look at this on the right-hand side. This is something I did a couple of weeks ago to plot a stock. I think this was a Kado stock, which, as you can see, is not particularly seasonal. And this is using Facebook Profit, which can be imported as a library within Python. Very, very, very simple, quick and easily to apply, very well documented, intelligently understands seasonality and flexible granularity, and throws a battery of techniques, as an additive model, throws a battery of techniques at the calculation. You can see here, there's actually quite a good mapping, I think, to what is the data with a 95% confidence. So that's what I would have used now. Can we move on to the next slide? Then the inventory. Well, the problem that inventory was a huge problem. We had this huge penetration of Japanese items into the marketplace. which made much of our inventory obsolete. People didn't want these remanufactured things anymore. They've got Japanese cars. So what happened was we had long meetings with the management team, and I do mean very long, on a regular basis, looking at sales projections in a volatile marketplace and the inventory to classify our stock into A, B, and C categories. And then we'd take the category C stock and we'd smash it up and we'd sell off the metals that were in that stock. We thought we're never going to sell that. So what have we got today? Well, we've got classification. So I would use a technique now, something like K nearest neighbors. So we can train the model to understand what's our A, B, and C stock as it's coming in, and any more stock that we've got coming in would then it would suggest to us what the classification of that particular stock should be, and then we can then go and change by exception anything we think shouldn't be the case, rather than having to go through everything through first principles, which was just terrible at the time. I remember long days. And the other area in inventory is clustering, because things were changing so quickly. So to identify the slow-moving and obsolete stock by manufacturer, for example, what is it that's happening here? It's which particular manufacturer is not doing particularly well? Is it a group of manufacturers? Is it in age? Is it the kind of starter alternator? What is it? Well, that's clustering, and again by continual monitoring, and we can then plot the behaviour of the clusters to see how the market is moving. As a business, have we got the right stock? Use this analysis for the marketing and purchasing strategy. Do we need to start having special offers on things? And rather than again having to build everything up from first principles, it would come and tell us from the data as it's happening what it thinks. Next slide. It's then warranty. So the warranty rates were going up, aging and degradation of warranty items. Again, long meetings to understand the warranty analysis work to identify the problematic brands, and the lag nature of the warranty returns against the volume sales made forecasting very difficult. So once again, very flexible tools these days for forecasting. I would use one of those to continually monitor and forecast the warranty data, and again, look at those issues based on those forecasts where the warranty was looking particularly bad. And then the same kind of thing as the inventory clustering, to identify those high warranty cost items by age, type, manufacturer, plot the behavior of the clusters and see how warranty is moving, and feed that into marketing and sourcing decisions, for pricing and for sourcing of these stock, and also what raw materials, etc., we're going to need to try and improve the quality of the warranty items, which are going to be the bad ones as they come in. Next slide, please, Larissa. So what benefits did this model bring? Well, it brought both short-term and long-term benefits. We recognised that the markets were shrinking. That was the key thing, and there's pressure on cash. We were able to do what-if analysis, and that ultimately led to a recommendation to restructure the capital base. So we closed down France, we closed down, we moved Spain into Germany, and we relocated the UK business, because we realised the capital base of this business has got to be changed, got to be reduced. It also allowed us to put together a very good case for the application for funds. So using this model and using a discounted cash flow model, I was able to demonstrate the additionality case to say, well, Department of Trade and Industry, if you support the business to this amount, that's the minimum we need to stop us having to close the business down and move out to Germany. And I used the model to prepare that case together with a discounted cash flow calculation. And I have to say, in all modesty, the Department of Trade and Industry said it was the best case it had ever seen. And it eventually led to a successful business transformation. So we moved the business out of its very cramped and Victorian location in the middle of Birmingham to a nice plush estate, business estate outside, and business was started afresh. And it was because of this sort of case, and because we were able to present very robustly this needed to happen, that we were able to get the financing to do that. So what was required to get to that position? Well, first of all, I had to build this model from first principles. I didn't have anything apart from spreadsheets. I had my background in statistics. I understood macros. I was a geek even before the word geek had been coined at that time, I think. I was very interested in how are we going to try and make these things better? How can we apply statistical and business knowledge? But it took lots of time and work. I had a staff of 25 at the time as a finance manager, and all the costing and all of that, and a lot of firefighting in the business, strategic sourcing agreements to sort out, and the rest of it. So I had to basically do all of this in my spare time, and I had a young family at the time, and you never get that time back. Very, very long days, but it had to be done. I didn't see any alternative. I had to do that and manage the finance side of the business. So sort of girded up my loins, as they said, and just get on with it, and let's get through it and get it done. And looking back on it, I'm very glad that we did, because it's one of the parts of my career that I'm most proud of. Next slide, please, Larissa. So how to go about it now? Well, I think life would be a lot easier now. First of all, the key thing is to understand the key drivers of the business, and you do that by knowing the people in the business and getting to know the business and understanding the history of the business, etc., the kind of business. So an awful lot of knowledge there, soft knowledge to be picked up. Understand the business issues. How much is one of the key things that I had was how much is the effort the marketing department's putting in going to change the irrevocable decline of sales trends? It's the short-term thing. Can we turn this business around? To try to understand that kind of thing. Understand what can we do with this inventory? Why are we getting all this inventory? Have we got the wrong stock? And the warranty issue, of course, I've talked about. Identifying the issues currently consuming finance time, because one of the things you've got to do, of course, is find the time to do this stuff. And if you're sitting in meetings all the time with lots of other people going through stuff, you just don't find the time. So you've got to get a handle on how you're spending your time in the day. Is this useful time or not? Is it value added or non-value added time? And get trained in the techniques. So as Larissa mentioned, I've got a qualification from Wilcott University. I've also done the Corbett qualification. Both of those I thought were excellent. And I know that Intel has also got some extensive online training. I'm looking at some of that at the moment. That looks really good too. All of the issues that I faced then, we'll be able to address now with Python and its libraries, in my view, such as NumPy, Pandas, SciPy, Matplotlib, and scikit-learn, which are all additives into Python, and Facebook Profit as well. We'll be able to leverage the power of the cloud, both for data collection and presentation. So rather than me having to carry around a computer and put it on people's desks, they'd have it all on their desks, and they have the dashboards coming up. We can make presentations easily. We've got continuously consumable data coming in and being absorbed and relevant for the team. And we could use techniques such as Dash and Plotly to make it all very graphical. And of course, Python interfaces very well with SQL, OLAP tools, and Excel. I'm just trying to show two examples here now. Next slide, please, Larissa. So here's a quick example, just to show what can be done very quickly for budgeting and planning, for example, to understand volume versus price. So as you've got data coming in on volume versus price, you could do a regression to understand the relationship between them. How does volume behave as the price goes up? That will give you a formula which you can then plug into your revenue calculation, which of course is price times the volume. And that will give you a quadratic type graph, as you see below, with a maximum point. And you can say, well, for budgeting purposes or forecasting, this is what I think the best price should be. And of course, you'd have a certain confidence interval around that, and you can play around with different prices, and it would automatically flex the volume for you as you play with those prices. And we've developed a model that does that we're looking at the moment. Next slide, Larissa. So this is an example of how we can use OLAP tools with the Python data. So this is a model that I built to do the efficient frontier, to calculate the best stock portfolio that we have. And on the left-hand side, you've got all the various portfolios you can have. As you move to the right of the left-hand top left graph, it gives more weight to current data. And the little wheel on the right-hand side, the radial graph, shows which of these allocations, if we use them in historical data, would have given us the best return. So that gives you an idea of the volatility of the data. And this is all driven by a Python program using machine learning optimization techniques, which then appears within the dashboard, which in this case I happen to have put into Excel. If you could just do the down arrow, Larissa, it should animate. So, oops, sorry, could you just go back to that previous one? Could you just click on it? You should get an animation here if you're lucky. Yes, okay. So you can see now, because it's an OLAP technique, we're looking at the FTSE 100 here, and you'll see in a moment this will change to the NASDAQ. Any second now. There we go. There's the NASDAQ, and all going from the same data, and it's self-service, user defined. And then we change it to the S&P 500, and then we can change it from a less risk-averse strategy to have a look at a more risk-averse strategy, in this case maximizing the Sharpe ratio. So all that data is there, and the user can just pick it up and look at it. So of course, I would have put something like that on top of the models that we've been speaking about. Okay, next slide, Larissa. So if you could just click on this one. So here we have an animated slide. This is actually the allocation of stocks. And what this does is it actually takes another dimension, in this case time, and allows you to see that dimension on top of the two dimensions you've got on the slide. So we can see here the allocations changing over time. But this could just as well be products, it could be customers, it could be the clusters that I've talked about, to see how the business is moving. And once again, this would be on somebody's desk to look at it. Next slide, Larissa. Okay, so this shows us the IBM model for what they call the AI ladder, what we need to do for AI. And they say you need to collect your data, you need to organize your data, you need to analyze it, and you need to infuse it, push it out through the business. And this is a very interesting set of steps because it aligns extremely well with the architecture of the data lake. If you could just click again on the slide, Larissa. So there we have a model for the data lake, which we say can ingest the data, we then govern and store the data, and then we apply the data, which, as you can see, exactly maps onto the AI. So if we're getting data lakes in, and you're deciding all the different data from different sources, big data, whatever, to get in, we can apply these techniques. So what kind of person do we need to apply the techniques? Next slide. So the kind of person I think that you need is, well, first of all, somebody who's curious and somebody who's keen. So somebody who's got business knowledge, obviously, somebody who's got the finance skills to understand what they mean, but somebody who's got the IT skills to be able to go off and try things and build things, and somebody who's got maths and stats skills to be able to understand how to analyze this data. But the key thing is these are not in isolation. These produce a synergy. And if you get somebody with that kit together, or train people up with that kit together, then they can use all of that in data science, and they can draw on that toolbox as and when required. And I think the sum very much there exceeds the whole exceeds the sum of the parts. Next slide, Larissa. So just to finish off, here's a quote from Brian Saha, the Vice President of Machine Learning of Amazon Web Services. This is just the beginning. The next phase of machine learning will deliver what scientists could only dream of, industrializing and democratizing machine learning. With purpose-built machine learning platforms and tools that can systematize and automate deploying machine learning models at scale, we're on the cusp of a major shift that will make it possible for all enterprises, not just the Fortune 50 companies, to use this technology and become truly disruptive. So I very much endorse that, and I hope I've given you an impression of how I think that might be done in an SME. So I think that's the end of it. So thank you very much indeed.